Labas rytas once again. But sorry that I will speak in English, but it is very simple English. I don't know English like foreign language. I learned in the school German and Russian. It was in time communismus, yeah. But now it's better, now it's all. But I have to learn also English. I'm autodidact in English. It's my communication between that has improved my English a little bit more and more. But I think that for you will be understandable, and eventually you can ask me for the details and so on. But I would like to speak about chemistry. But chemistry as part of STEM education. The same like you. Okay. Yeah. It's a little bit, how to say, mystery. Maybe something mystery. Something too much difficult. What chemistry? I don't know what is in Lithuania, but in Czech Republic we have some problem with chemistry at lower secondary, in elementary school. Many, maybe not so much pupils, but so much teachers are worried about chemistry. Why we need the chemistry? We can write to chemistry at the 15, 16 years. But I think it is pity. It is pity that we not include some small elementary phenomenological chemistry also inside of science education. GAMTAMOKSLINIS. Okay. So, and a few words about me. I am coming from Czech Republic, now here, but we are not in the center of Europe. Lithuania is in the center of Europe, but we are, you can see in the red color, we are heart of the Europe. We are not center of the Europe, we are heart of the Europe. So, and I am coming personally from this region. And this region, the name of the main city of this region, like Utena here, is Hradec Králové. And Hradec Králové in English translation means Queenstown. Queenstown, not Kingstown, but Queenstown. But in Middle Age, the king was in Prague, and queen was in Hradec Králové, in Queenstown. But it was very practical to have 100-kilometer distance between king and queen, and they can visit, they can
for safety reasons.
Oh, okay. So, but now I'm working in Prague. I'm working at Charles University. Charles University is the biggest university in Czech Republic. It was the first university in Europe in the east side from River Rhine. East side from east direction from River Rhine, you know River Rhine in German, and first university was in Prague, Charles IV University. And also something about Czech Republic, maybe, maybe you know that chemistry in Czech Republic is connected with breweries. You have also here brewery, Utena's, I know very well. But yesterday was in the restaurant, not Utena's, only Svituris. Okay, but you know that we have very nice chemistry in Czech Republic. We have about 300 breweries in the small country. And also maybe you know Czech philosophy. Czech philosophy, it is good soldier Švejk. Maybe some of you know this novel about Švejk, two parts about something like military from the First War and so on. And also we have some kind of technology. You know, maybe Škoda. I saw many Škodas in the street. And also we have a big pedagogist in our country, maybe you know, Jan Amos Comenius. It is a pedagogical program. All back to chemistry. I know that the director of the STEM Center is from history. And I would like to start with history. And where was the chemistry in the history? Was the control of the fire. Many millions years before Christ started chemistry, maybe proto-chemistry, pra-chemistry. The first chemistry, no knows the term chemistry, but each used the chemistry, knowledges, experiences, and so on. But also, you can see that we have the periodization of the ages, but somewhere here is the fire, using of the fire, control of the fire, control, organizing things by the fire and so on. But sorry, it is your case, but it is not my case, and we can go more in the chemistry. We can go on the timeline of materials. But if we would like to include chemistry in elementary science, early science, we can work with materials. Many different materials are around us, and we are working with the materials. And also in history they are working with materials. They started with pottery, they continued with copper, and also gold and silver. And next from the copper to bronze. And bronze was more hard like copper and was better for some guns, for battles and so on. And from the bronze next to the iron time. And iron was better for preparing like copper, and more iron they have in the history like copper. And many times the colleague knows very good in history that it changing winners. Who was working with iron was better in technology, like who was working with copper, and so on and so on. You know it, I think, very well. And some pictures, gold vessel from 3000 before Christ, and the washing of gold in ancient world, and also tools made from the copper. And next, we need a little bit harder, and we need the bronze, and so on. And also, I have my follower, colleagues from Greek, will speak about AI. But I also prepare my pictures by AI. But you see that AI a little bit worked behind me, but nice pictures. How to go with help of the chemistry, maybe hidden chemistry, from the pottery to the glasses. Also, my wife is working with glasses. Also, not only beer is typical for Czech Republic, also glass art is typical for our country. And you can see at many steps how to work with the pottery and to finish for the glasses. Next, dies. I see many nice women here, and probably you like the dyes. And the dyes coming from nature, that is really nature chemistry. The first one would be indigo from the Egypt. Next, purple fire from the sea. It's nice violet color. And next one, it's animals, also colors from animals, you know. And also some fixing of colors. Not only color textile, but must be continuing color and fixing of the colors. Okay, and last AI picture, it's about procedure. Yesterday in radio, we spoke here in Utena's radio about new strategies in science education. And my speech was oriented, we need more about procedures, more about methods, methodology, like about context. We need to know how to observe, how to measure, how to experiment, how to models, and so on and so on. But you can see that first organizing procedure, maybe one of the first, not the first, one of the first, was very nice procedure, very nice method, distillation. But distillation was observed. First one in the kitchen, in the Prague kitchen, yeah? And it was how to go water from the liquid form to gas form, and next back to liquid form, and cycle. And you are working, somebody of you probably are working in primary education. So, yeah, okay. Somebody is working in pre-primary, maybe, also pre-primary. Okay, we have. And you are working with water cycle. I think, yes, it's understandable, yeah. And the first using of distillation was not for spirits, for alcohol, but using for essences, for smell, for this small amount from the roses, for small amount from different nature things, and to prepare nice smell and to prepare something for additional part. And also initially, and from here, we have the feeling about chemistry like mystery. It's also distillate of idea, distillate of spirit from something. It was very close connected, you know, the era In chemistry, it means alchemy. Alchemy was from one side, from theoretical side, very big mystery, to prepare stone of ideas, to prepare elixir of ions, to prepare, what was the third one? Stone of ideas, elixir of ions, and transformation of metals. From iron to prepare gold or something like that. It was three main objectives of the alchemists. Okay, but we can go back a little bit more from history. We can go to apparatus and finances. It was enough only coal for copper, but not was enough for iron. For iron we need the flame, and also we need more oxidation, more oxygen. It was technology oriented, and also leather tanning, soap, sulfur, wine production, medicaments, and so on, but it's chemistry. But now, question for you. If colleagues spoke about science, STEM education, science, I think it is very clear what means biology, the term of biology. All knows this term. Bios is life. In Czech language, život. In your language? But no, it is Russian. It is Russian. And what is life in Lithuanian? Life is complicated. Okay. So, but we know geography. It's clear. Geos. It's art. All nouns. Physics. From Greek, physics is some moving or something like. But what about chemistry? Where is base for the term chemistry? Where, you know? Chemistry. What is the word chemistry? Biology is clear, physics is clear, geography is clear, geology, colleague, here is also clear, but what about chemistry? It is very complicated, nobody knows. Some my students answered me alchemy, but it is no answer. Alchemy, it's the same like chemistry, yeah? Alchemy is from Arabian language, alchemy like der, die, das, or and so on. But we have four sources, possible sources. First one is from Greek. We have the colleague here from the Greek, ancient Greek. Chemia was book, name of the book about transformation, about changes. Maybe it can be somewhere the start for the term. Second, chemists. Alchemists are used liquid, theoretical liquid, mystery liquid, chemos. If we will find the chemos, will be simple to make from iron to gold. But no time they found it. Third one is Hebrew. Hebrew name for Egypt, it was Chemia. The reason was that in Hebrew, Ham is black. Ham is black. And River Nile has, at the end, close the Mediterranean Sea, and a nice fertility. It is black earth, black soil. But why Egypt? Alexandria. Maybe you know. Alexandria was big city with big academy, and all knowledge in this year, maybe 200 years before Christ and after Christ, was concentrated all knowledges in Alexandria. But maybe the name Chemia of the Egypt could be start. Chemistry is knowledge. Chemistry could be from the Chemia. And also we can go to Chinese. And in Chinese language, do you speak somebody Chinese? No. Me also not.
Just beginners.
Just beginners? Okay, you.
Yeah,
So,
but we need.
If you are beginners, you know this special, please read it. but this is to mark, it's possible to read. Give me yay. Did you listen? chemia, something like chemistry, something like, and also chemistry. These two marks, and also could be this. But you can see, with chemistry it is complicated. Not so simple like biology, physics. And we have also some periods. Very quick, I will go through the periods. I spoke till now about proto-chemistry. And proto-chemistry could be very nice for using in early chemistry education, in pre-chemistry education. And in periodization, we are speaking about using of the fire as a start of the proto-chemistry, and somewhere at the finish of Egypt, Alexandrian Academy of Sciences. It is somewhere in the 3rd or 2nd century. And now something for Greek. Do you know this schema? Do you have in your memory something from courses of philosophy? I think yes. Who was the author of this schema? It's crucial question. Aristotle. This is Aristotle's schema. What means substance? What is substance? What is all around us? And it was really first step in the theory. Before I speak about practical experiences, about the dyes, about pottery, about iron, about copper, it was all connected only with experiences. Trial and error. If it's good, we can follow the first step. If it's not good, we have to stop. And the first approach for the theory of the substance was ancient Greek philosophy. And this one is Aristotle's schema, and you can see it is my preparation for tomorrow, for your workshop with me, and it is 4 ancient elements. The first one is air, second one is water, fourth one is air, third one is air, and fourth one is fire. And what was before? Somebody of you knows philosophy? You know, I know. Mono approach. Monoism, maybe from the Greek. Thales from Miletus said, all around us is coming from water. Hephaestus said, all around us is coming from fire, and so on. Pythagoras, all around us is coming from numbers, and so on. So it was mono approach, but Aristotle made these combinations. Steam approach. So really steam approach. And you can see here we have something what is very understandable for us. It is something like properties. Properties. Wet, I know what means wet. Cold, I know what means cold. Dry, I know what means what means dry, and so on. And combination of two principles is giving the elements. It was simplification. This simplification from my side. It was first theory for the substances, and this theory was continuous theory. But maybe you know what was parallel theory in ancient Greek. It was particles. It was particles. Leucippus and Democritus. They speak about small particles. Atomos. Atomos is not splitting. Atomos is splitting. This is not splitting, and atomos is splitting on the small walls, and so on and so on. But this theory of Aristotle was started about 400 years before Christ. Until 17th century, all in science was based in this theory. Not on the atoms. Atoms was developed in the same time, and it was phantasmagoria. Nobody knows that we have the atoms. Nobody see atoms somewhere. But it was put out in this time. And 2000 years, all science worked on the base of this theory. Okay, second theory. We spoke about alchemy, but only picture. only because we have a very nice movie in Czech Republic about alchemy. But alchemy was flowering in Prague, especially in Prague, and the castle of Rudolf II was big alchemy labs, big alchemy group. And now you can read in some books that management of science, management of research is started in Prague at castle in 16th, 17th century, and organizing this kind of researchers, alchemists in the Prague. So, next periodic is iatrochemistry. Do you know what means from Greek iatro? Iatros? Iatros is medic, doctor. Yeah. It was oriented, the name is from Switzerland, Paracelsus, and it was the period iatrochemistry, too much oriented to medical science, too much oriented also metallurgy, medical and metallurgy. And also we can use the different kind of things in chem labs. And next is Robert Boyle. Robert Boyle was in 18th century big chemist, scientist, and which wrote the book Skeptic Chemist. Skeptic Chemist was English word maybe, and the speech was nullis in verba. Nullis in verba, we have to make the experiments. Finish with Aristotle theory, this phenomenology, this continuously, and we have to go back to the experiment. So, and here is a lab from this time, and modern period is connected with Mendeleev. You know all, you are remembering periodic tables, but I'm a chemist, I'm a chemistry teacher. But from my side, it's not necessary to learn periodic table like memorization. No, I don't need it. I have many periodic table on the table, on the computer, on the TV, and so on. It's not necessary to learn, but it's necessary to understand what means periodic table. I think that you have in your memory what means periodic table. And next information, we prepare differentiation in chemistry, inorganic, organic, biochemistry, and so on, but also integration of disciplines and so on. But we have to go very quick now. What means chemistry? Chemistry means that is science about substances and their changes. And now, one task for you. So, okay, one task for you. Please take one probe for the pairs or the trios at your hands, please. Only one for couple or for trios. Also for your group. One for the pair or one for trio. I wrote for you some mystery. White powder. No, white powder for you. Don't worry. It is not poison. It is not poison. Don't worry. It is not sugar. Don't eat. Many times when I am working with this experiment in the school, my small children are using the mask for safety, but you don't need it. You have my confidence that you are not tasted by So, and please, take very small, half of the small spoon and put inside the probe, please. Okay, I have for you too. Is the same powder for you, only half of the small spoon, half of the small spoon inside the probe. Yeah? And next step will be you have this instrument, and please put this little bit, okay, one step, and put inside the probe. And for your group, I will give you also. Yes, please, the water inside. And why 30 seconds? What happens? 30, maybe 40 seconds, you have to wait. And after 30 or 40 seconds, please try to take the probe on the bottom up. What happens? What happens? You can see what happens. After 30, 40 seconds. After 30, 40 seconds. And now you can try. Carefully. What happens? So, and if you take the water, you can make second round. You can make second round with water. And plus next amount of the water. And third round, and fourth round. And you can put maybe half of the probe with water. And after 30, 40 seconds, you can try to take the bottom up. You can make the rounds. You can make the rounds with water. Do you have some idea what is this substance? Do you have some idea what is this substance? Where we can use it? Where we can use it? Where we can use it? You can make a second round. You can make a second round. Do you have some idea where is this substance? Where we can find this substance? Here is my answer. Here is my answer. Here is my answer. And it is substance generally named superabsorbents. Superabsorbents. And we can find it. We can find it in children diapers. We can find it in diapers for adults also. And now we can find it also in agriculture. In agriculture, maybe not in your countries, in Baltic countries, in Middle Europe, the soil very dry, very dry. But when we are producing trees, we have to use these materials inside of the soil, and step by step it's coming out the water, and it means that dry is not so strong. And something about explanation. What is what is this material? Do we have here some chemists? Are here chemists? Yeah, you can explain. Do you know this substance? Superabsorbent. What is base for this superabsorbent? Please. Which kind of chemical substances you estimate inside? Polymers, yeah? Polymers, some kind of polymers. And base for these polymers is adipic acid, only for chemists, it's okay. It's not important. But for us, we can see the small part of the water, the small ball, is something like this ball, and absorption make bigger and bigger ball with the water. And it is a little bit diffusion, it is a little bit plus-minus connection, and so on. But this kind of materials can make maybe 300 times more absorption like its weight of this material. But sometimes it is 50 or 100, and maximum could be 30. And also, this is patents for these materials, that it can be it can be very good oriented for 37 Celsius degrees. Why 37, you know? But if temperature of the liquid is less, like 37, absorption is less. And if it's more, like 37, absorption is more. It is typical STEM education. It is technology, but I know as chemist that it is some kind of polymer. But I know now the details. I don't know the details. I know only this. But I have here some video. Maybe we can use the video I don't have time, probably, time. I have time.
10 minutes.
10 minutes, okay. But maybe start of the video. We can. My colleagues from Czech Academy of Sciences is English people, and he is very productive. It's not really how it is.
Just press. Click on the link.
It's my class. Oh, sorry. Maybe video will come tomorrow. Video will come tomorrow. Sorry for it. But in the video is some game with this super absorbent, and the colleague made some joke with his wife, and it was about to work with the super absorbent. Okay. And to prepare for wife some surprise, 3 cups. And in 1 cup was the super absorbent, and the second cup and third cup was empty. And put a little bit water for the first one and make some games. Where is water? Here. Okay. And next, put the water in the cup with the super absorbent. Where is water? Here. Nothing. And you can make different kind of experiments with this. Also, with smart textile, for example, it is different, not super absorbent. It is absorbent of warm energy. Maybe you know it's a special kind of textiles, but you made some shake and the textiles is warm. And next, you can maybe the warmers are using in winter time some sacks with some substances, and we can make shape and it's warm, and so on and so on. We have many different substances. Also, chemistry, for the early chemistry, is very nice to work with mixture. To work with mixture and to separate mixture. We have many different kind of separation, how to splitting from mixture, splitting the separate. And one of the nice methods is, you know, what is the name of these methods? And I use the markers. I use the black markers, and I put the black markers 1 point in the paper, and I make the knot on the water, and water go up, and from the black color I receive this kind of color. Very nice, interesting for small children, they can work, but you need special markers with water based, not ethanol based, but water based. We will taste it tomorrow. And also, now it's difficulty in the chemistry, and the difficulty is to see inside of substances. How to see inside of substances. And chemistry or science or STEM disciplines are using methods modeling. Our imagination, what can happen inside. And I have for you last experiment, and I would like to invite for me 2 volunteers. Please help me. 2 of you, please help me. Work with demonstration here, and please, I would like to ask 2 of you, please help me. 2 volunteers, please help me. It's nothing dangerous, and we would like a little bit, 1 and 2, and next you, yeah, please. So, and I would like to ask you, sorry, I have at lab ethanol. Can you bring me from the lab ethanol? Sorry, it's my mistake.
Nice.
Oh, sorry. Okay. We need but it is a little bit science mathematics. I will explain this experiment, maybe you know it. And the colleague prepared exactly 50 milliliter of ethanol. And second colleague prepared exactly 50 milliliter of water. 50 milliliters of ethanol and 50 milliliter of water. So you can start, you can prepare exactly, you can use the table and prepare 50 milliliter and you 50 milliliter of ethanol. And now mathematicians here, what means 50 and 50? We can ask artificial intelligence and artificial intelligence can respond 50 and 50 is 100. And we can state the hypothesis that we can mix 50 milliliter of water and 50 milliliter of ethanol. We can receive. So it will be for the colleagues which one bring.
But you need to use special ethanol, Becherovka.
It is not good. Only the small. Okay.
Please do not consume.
Per mažai?
Please do not consume everything because.
Sakė per mažai.
Maybe it is enough. I have big bottle on the lab. I have big bottle.
So you need some more?
Yeah. We need 50 milliliter. 50 milliliter. Maybe
Should be more than. Should be more than 50.
Should be. 50. Okay. 50. Yeah. 50 plus 50 in mathematics is each time 100. Okay. And colleague, chemist, please. Chemist, please. Your floor is yours now. And please make the mixture with 50 of the ethanol and 50 of water. Please make the mixture. Okay. We have 50. Yeah. It's 50 exactly. I think it's okay. Thank you very much. Thank you very much. And now the colleague, please. And make the mixture 50 milliliter of ethanol and 50 milliliter of water. Yes. Somebody of you maybe knows this experiment. You know, ask him, it's you know. So, and what is final amount? What is final volume? Please. 96. Please take on the table. Please check. It's right. How many? 95. And please you. We have first result is 96. Second is 95. 95. Oh, doesn't function. Mathematics doesn't function. It is chemistry. No explanation now. No explanation. And thank you very much. And next two, please. Next two, come to me. Next two. Please. Two volunteers. Next experiment. Last experiment. Can I ask you? And you? Okay. And please, your task will be more difficult. And please prepare for me 50 milliliter of green peas. In Czech language, hra. Small. Please, 50 milliliter of green peas. And for you, I need 50 milliliter of mustard seeds. Mustard seeds. Small balls and big balls. Maybe you estimated what will come. I have last cylinder. Yeah, it is not so simple like liquid. It's not so simple like liquid. And we need 50 milliliter of green peas. Or we can use the lentils. And here we can use 50 milliliter of mustard seeds. It's also, we can use something small, couscous or bulgur or something like that. It is new. Okay. And last experimenter I have 100 here. You? No. who is willing to help me?
Big boss, big boss.
Big boss. Okay. So do we have approximately 50, and you have also 50? It's 50. And your task is to make the same mixture right from liquids and here from the sinks. And little bit and little bit. Yes. Okay.
Vitalija, užeikit už stalo viską, kad matyti.
Okay. But all must put inside, nothing else. Okay. Do you know the fairy tale about Aschenputtel? About this special princess? Which one is sorry. Hey. 1, 2, 3. Okay. Yeah. And maybe you estimate what will happen. So, and what is 50 plus 50 now? 90, 95? 95 is here, 95 is here. And now we have, thank you very much, thank you very much. We can shake also, we can shake. Okay, thank you very much for your help. And now we have the explanation. It's the same procedure. Procedure here was mixed two liquids. And here we prepare real model of these liquids. Model of ethanol could be mustard seeds. Model of water could be green peas. And together it's what is the phenomena which one now we confine? Diffusion. Diffusion. Molecules of ethanol is going inside in the gaps between molecules of the water. And a little bit, maybe my colleague chemist could protest a little bit, but here we have the big one model for water, and maybe you have in your memory shape of the water molecule and shape of the ethanol molecule. But on the table, and you can see that ethanol molecule is bigger like water, but in reality, ethanol molecule is smaller like water. But explanation is now clear that we have the molecules, and molecules are going inside and make the mixture. And it is a reduction of the volume. So this kind of experiment, I think, could be used also for early education, and they can be a little bit explained about principles. And what next? Next, you can use something how to confine diffusion. You can bring some color substance and put inside, and maybe you know how to demonstrate diffusion. But you demonstrate diffusion, and here you explain diffusion. But we can see that here I can make also from AI, this is water, model of molecules of water, model of molecules of ethanol, and here is mixture, but also is cheating from ChatGPT, is cheating, but here is not additional volume, but here is the same volume, but we know that the same volume, it is not right. So, and we can work in different laboratory at home. We can make different chemistry at home. We can make different chemistry at kindergarten. We can work with the kitchen. We can work with mixtures. We can paint, clean, molecular gastronomy. It's now very popular in our country to prepare balls, small balls, bubble tea, for example, and so on and so on. You know. And one invitation for tomorrow. Tomorrow we will work in some workshop, which one is oriented 4 is 4 ancient elements. We will work with experiments about water, experiments about fire, experiments about lead, and experiments about iron. And please, I have to hear a little bit sad message that my colleagues from Nuremberg, from Bavaria, developed this concept with me together, but he was died 2 years ago. But on his memory, I would like to show you this concept, and tomorrow you can try few experiments. Thank you very much for your attention.